Hello again. In our last video, we looked at the problem of trying to send the robot to move forward to the next wall and then back to where it started. And at first we succeeded in moving it forward to the next wall, but then we had no idea how many steps back to take. So then we had the clever idea of keeping track of how many steps the robot had taken so that when it gets to the wall, it would know how many steps to go backwards. And that was all we achieved so far. So right now our robot goes to the wall, and as it goes it counts, and this is how. We realized the robot needed to remember how many steps it's taken, so we declared a variable to store an integer value, an int, and initially the robot had taken 0 steps, but then as we move, not only do we move, but we increment the number of steps from the start that the robot has taken. So this line, remember, means retrieve the number of steps the robot took, add 1 to it, and store it back in that variable. And then just for fun, we printed out how many steps it had taken as it ran using that system.out.println idea. But I'm gonna get rid of that line since it wasn't essential to my program. And we're going to look at the challenge of getting the robot back. So having taken all these steps, when we get to this point, num steps from start is a variable that should know how many steps the robot is from wherever it happened to start. So if the robot starts in the position you see here, I believe when it gets to the wall that it will have moved 8 times, and therefore it should be remembering the number 8. And now the challenge is, how do I tell it to go back that many times? How do I tell it to go back that many times? And we can do that. Here's how. Well, I need to move backwards repeatedly. In fact, I'm going to make a note here, by the way. Num steps from start is total number of moves. Okay, at that point, I want to go back. That means backing up repeatedly, and I think I mentioned I have a method called backup in this same file, so I can just say backup, and I want to back up repeatedly, so that tells me it should probably be inside of a loop. And then the question is, when do I stop backing up? And you may be thinking, well, you back up when you get all the way up to the wall, but that's not true. If I start here, moving to wall and back should take me here. And if I start over here in this dark square and I move to the wall and back, I should end up back in this dark square. So I need to remember, I need to end up back where I started. And to end up back where I started means that the place I stop should really depend on the number of steps. So we want to use this num steps from start in order to get back, and since that determines when I stop, it should be part of my condition. Now I've got a couple options. If my robot is here and it starts moving forward, counting 1, 2, 3, 4, 5, when I get to the wall and I'm thinking 5, I now have a couple options. I can go back and think to myself 1, 2, 3, 4, 5, and when I reach the number 5, since that matches the first number I counted, I would know to stop. And we could do that. In fact, I'm going to do that really quickly just so you can see it. That means we need to keep track of 2 numbers at once. The number of steps overall and the number of steps I've taken to go back. So if I need a second number, that means I need a second variable. Num steps back, I'll call it. And initially the number of steps back is 0. And every time I back up, I will increment. So we'll say num steps back gets the value of num steps back plus 1. So we'll increment that variable. And I'm going to do that when? As long as, so if num steps back is 3, but num steps from start is 5, what does that tell me? It tells me I haven't backed up enough, right? Because num steps back is going to go 1, 2, 3, 4. When I get to 5, I should stop. So if the number of steps back is less than the number of steps from start, then I haven't backed up enough. So I'll back up one more time, I'll increment my count, and eventually I will get up to a point where the number of steps back matches the number of steps from the start that I took originally, and in which case when they match, one won't be less than the other, so this condition will be false and the loop will end. I'm going to show you the same problem solved in what I think is a simpler way, but first I want to do this. So I'll compile that, and we'll load up my little hallway again. Here it is. And we'll move a couple times just to confuse the robot. So the robot's now here on this light square. And we'll call that method, which was called goToWallAndBack, which I happen to know is in a file called lesson. And we'll see if the robot really does go to the wall and back. Okay, every time it backs up, you see all that turning around, but that's okay. Does it stop in the right position, facing the right direction? Yes, it does. It works. So that's excellent. But rather than prove to you that this code works, I want to show you an even easier way of doing it, because it turns out we don't need our robot, let's see, in this case, 1, 2, 3, 4, 5, 6, 7. We don't need the robot to remember the number 7 and how many steps back it's taken. There's a more clever thing we can do. Instead of going 1, 2, 3, 4, 5, 6, 7 and then counting back 1, 2, 3, 4, 5, 6, 7, we can say 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1, 0. Or 7, 6, 5, 4, 3, 2, 1, depending on how we like to think of it. In other words, what if instead of remembering the total number of steps, we treat this like it sounds, as if it's the number of steps from the start. And then we don't need to remember the number of steps we've taken backwards, which means this condition is going to change, and what we do here is going to change. Here's the idea. Suppose when I get to the end, I'm 5 steps from the start. Then I back up. How many steps am I from the start now? Now I'm 4. And in general, if I'm num steps from start, and then I back up, how many steps am I from the start now? I'm num steps from start minus 1. And I should take that new decremented, decreased value, number of steps from start minus 1, and say, well, now that I've backed up, that's the number of steps from the start that my robot is. So every time we back up, we'll decrease our number. We'll decrement the number. So if num steps from start is 5, I need to take 5 steps back. If num steps from start is 2, I need to take 2 steps back. If num steps from start is 1, that tells me I'm still 1 step from the start, so I'm not done backing up. So as long as num steps from start is greater than 0, then I haven't reached the start, in which case I should keep backing up. Let's prove that that works. I think this is a nicer solution. Anytime I can write code that remembers one thing instead of 2, that is a good thing. Oops, sorry. Here's my hallway. Oh, look, it's red, white, and blue. I think it looks like the French flag to me. We'll move a few times, and then we'll try our method. So it should go to the wall and back to where my cursor is right here. The suspense is killing me. Will it stop at the right spot? I know it's killing you. And yes, it stops at the right spot. So this is good. I want to show you that this is not the only thing we could have written here. There are many, many tests that would have worked here. Can you think of another one? Well, we could say, while the number of steps from start is not equal to 0. Now, not equal to is not the same as greater than. But knowing that this number will be positive, and I'll be decrementing until I get to 0, keep looping as long as it's greater than 0 ends up being equivalent to keep looping as long as it's not 0 yet. Likewise, keep looping as long as that number is at least, that's greater than or equal to, at least 1. That also works. And then, of course, we can mess with you. Not only can we say loop while it's greater than 0, but we can loop while 0 is less than it. That's a confusing way of looking at it, but you might prefer that. Anyway, I happen to prefer loop while it's greater than 0, loop while it's positive. In other words, loop while there's more steps left to take. While there's more steps left to take, back up, decrement the number of steps we are from the start. When you get to 0, you must be on the starting square, so stop looping. So that's kind of nice. It's not actually a very useful method, right? It simply goes to the wall and back, which no one would ever do in their right mind. But suppose instead of going to the wall and back, I wanted to do some work, accomplish something useful in this method. Like maybe I want the method to measure how far away the wall is. So I want to write a method that determines the distance from the robot to the wall, which means the robot will have to go to the wall and back, but it should come back with an answer. So I'll let you think about how to do that, and you might even try that before you run the next video, where we'll see how to determine the distance from the robot's position to the wall by moving to the wall and back and counting in the right fashion. I'll see you in that video.